All right, so for part A, it says an object of mass of 80 kilograms is accelerated by a force of 30 newtons, and we need to find its acceleration. So, first off, we need to figure out our starting point. In our case here, it's Newton's second law, F equals ma, which is awesome, because our second step is to figure out what we need to solve for. In our case, we need to solve for the acceleration a. So we take the force, we divide it by the mass, and we get our acceleration a. Third step is to plug in our actual values. So in our case here, we have a force of 30 newtons, and we have a mass of 80 kilograms. So 30 newtons divided by 80 kilograms gives us our acceleration a, which turns out to be 0.375 meters per second squared. For part B, it says, what is the mass of an object that is accelerated at 15 meters per second squared by a force of 135 newtons? So, going back to our problem, again, we first need to figure out our starting point. Again, in this case, it's F equals ma. But in our case here, we need to solve for the mass, m. So we take the force divided by acceleration, and we'll get our mass, m. And then next case, we just need to plug in what our F and A was. In our case here, our force was 135 newtons. Our acceleration was 15 meters per second squared. So we take 135 newtons, again, divided by 15 meters per second squared, and we get our mass of 9 kilograms, which is awesome. Part C says that a ball has acquired a speed of 21 meters per second when a force is applied over a distance of 0.75 meters. If the ball has a mass of 2 kilograms, what is the force applied? So this is a little bit more of a difficult question because it's actually a two-part question. So first off, we need to figure out our starting point. In our case here, it's the third kinematic equation here. What we need to do here is we need to solve for acceleration a. The reason for that is that we're given our final velocity, our initial velocity, we're assuming it's 0, we're assuming it's starting from rest, and we are also given your delta x here. So all that's left, our only unknown, is our acceleration a. So for our second step, we just need to plug in what we have for each of those values. So in our case here, we have our final velocity is 21 meters per second squared. Our delta x is 0.75 meters. Again, we just do that math and we get an acceleration of 294 meters per second squared. And for a third step, we actually need to solve for our force. So we go back to Newton's second law, F equals ma, and we plug in what we have. So our force is equal to, our mass was 2 kilograms, times our acceleration we solved in the previous step. So 2 times 294 meters per second squared gives us our force of 588 newtons. All right, hopefully that helped.